Over the past few decades, China has moved far beyond building isolated landmark projects. Instead, it has been developing a vast network of interconnected megaprojects, where each new achievement supports and strengthens the next, creating an integrated system that drives multiple strategic industries forward at the same time. From highly automated factories, producing advanced structural components at an unprecedented scale, to floating wind farms operating far offshore. From shipyards comparable in size to entire cities to massive tunnels stretching beneath the sea, China continues to expand its engineering capabilities at a pace that few countries can match. While many nations spend years navigating regulatory hurdles, political debates, and lengthy approval processes, China continues to push ahead with projects that are larger, more complex, and increasingly sophisticated. But this goes far beyond infrastructure alone. What is emerging is a broad transformation that spans energy, transportation, manufacturing, construction, and even space exploration. Today, we are counting down 20 Chinese megaprojects and technologies that demonstrate just how far this engineering powerhouse has advanced. 20. Deep Sea Number 1. If you sail 150 kilometers off the coast of Hainan Island, you won't just see endless blue water. You'll find one of China's most ambitious engineering achievements quietly operating beneath the waves. Deep Sea Number 1 is far more than a gas field. It is a floating fortress of steel and innovation, extracting clean energy from more than 1,500 meters below the surface of the South China Sea. Developed by the China National Offshore Oil Corporation, the project represents more than a technological success. It symbolizes how far China has advanced in mastering the ultra-deepwater frontier. Officially operational since 2020, with 21, the Deep Sea No. 1 gas field produces approximately 3 billion cubic meters of natural gas annually, enough to meet roughly a quarter of the energy demand of the Guangdong, Hong Kong, Macau Greater Bay Area. That means millions of homes powered, businesses supported, and factories supplied by a massive structure engineered to withstand some of the harshest conditions in the ocean. The centerpiece of the project is the platform itself, Shanghai Yihao, the world's first 10,000-ton semi-submersible production and storage platform. Imagine a structure roughly the size of 2 football fields and as tall as a 40-story skyscraper, floating steadily in open waters. Built in Shandong Province, this steel giant utilizes an innovative truss design that is lighter than conventional structures while maintaining exceptional strength. Engineers carefully calculated every force, weld, and weight distribution to ensure long-term stability against waves, currents, and extreme weather. Beneath the deck sits a buoyancy system, supported by 4 massive columns that keep the platform stable even during severe offshore storms. This is not merely an oil and gas platform. It is an engineering fortress designed to thrive in one of the most challenging environments on Earth. And this is only the beginning. Phase 1 entered operation in 2021, while Phase 2, scheduled for late 2025, is expected to increase annual production to approximately 4.5 billion cubic meters by tapping into reserves estimated at more than 150 billion cubic meters. Projects like Deep Sea No. 1 strengthen China's energy security while pushing offshore engineering technology to new heights. It serves as a bridge between the deep ocean and some of China's most dynamic urban centers, including Hong Kong and Zhuhai. And while Deep Sea Number 1 dominates the waters below, China is also building extraordinary structures that cross the sea above. 19. Shenzhen-Zhongshan Link. There are bridges, and then there is the Shenzhen-Zhongshan Link, a project so ambitious that it literally dives beneath the sea. Opened in June 2024, this $20 billion mega-project connects Shenzhen and Zhongshan across the Pearl River Delta, reducing travel time from nearly 2 hours to just 30 minutes. What once felt like a lengthy road trip now feels like a quick commute. At the heart of this engineering masterpiece lies its underwater tunnel, a 684-kilometer, 8-lane passage built with remarkable speed and precision. How remarkable! The world's widest underwater shield tunnel was excavated in just 110 days using Shanhei, a tunnel boring machine with a diameter of 17 meters. Think of it as a gigantic mechanical earthworm carving through the seabed with extraordinary accuracy. More than 500 massive pipe rings were assembled like pieces of a puzzle to create a watertight, earthquake-resistant tunnel capable of withstanding immense ocean pressure. But China didn't just build big, it built smart. Advanced monitoring systems and Beidou satellite navigation continuously oversee operations, helping maintain smooth traffic flow while enhancing emergency response capabilities. Even more impressive, the project was designed with environmental protection in mind. Instead of relying on large-scale blasting operations, engineers used highly precise mechanical excavation techniques, helping preserve the habitat of the endangered Chinese white dolphin. The Shenzhen-Zhongshan link is more than a transportation corridor. It is a showcase of scale, speed, innovation, and environmental awareness. By setting multiple world records, the project has redefined what is possible in modern bridge and tunnel construction. It stands as a powerful symbol of China's determination to connect its cities faster, smarter, and more efficiently than ever before. But China's ambitions extend far beyond transportation. The next project is helping redefine the future of nuclear energy itself. 18. HTRPM Pebblebed Nuclear Reactor. Nuclear power is not a new technology, but what is happening at Xidaobei is helping rewrite the story of nuclear energy. Located on the northeastern coast of Shandong Province, the High-Temperature Reactor Pebblebed Module, or HTRPM, is the world's first commercial fourth-generation pebble-bed nuclear reactor. Rather than relying on traditional large water-cooled reactor designs, this modular system is smaller, more flexible, and engineered with safety as a primary objective. At its core, the reactor uses helium as a coolant, graphite as a moderator, and thousands of fuel pebbles protected by advanced layers of carbon and silicon carbide. The result is a design focused not only on efficiency, but also on exceptional safety. In the event of an emergency, the reactor can naturally reduce its temperature without requiring active intervention or external cooling systems. No frantic emergency procedures, no massive backup water reservoirs, just the laws of physics working as intended. But electricity generation is only part of the story. The facility also produces high-temperature steam that supplies heating to nearly 2,000 households, replacing thousands of tons of coal each winter and reducing carbon dioxide emissions by approximately 6,700 tons annually. That is clean energy flowing directly from a nuclear plant into homes and communities. Connected to the power grid in 2021 and fully commercialized in December 2023, the project represents a major milestone in nuclear innovation. The current system uses 2 reactor modules feeding a single 210-megawatt steam turbine. And this is only the beginning. China is already developing the HTR-PM600, a larger version that will combine 6 reactor modules with a single turbine, dramatically increasing output and efficiency. By embracing pebble-bed technology, China is not simply pursuing clean energy. It is helping shape a new generation of nuclear power, safer, smaller, and more adaptable. Xidaobei is more than a power plant. It is a glimpse into the future of energy production. 17. Xiong'an New Area. About 100 kilometers south of Beijing, an entirely new city is quietly rising from the ground. But this is not just another urban development project. This is Xiong'an New Area, China's bold experiment in designing a city for the 21st century from the ground up. Announced in 2017 by President Xi Jinping, the project was conceived not only to ease the pressure on Beijing's overcrowded infrastructure, but also to redefine how future cities are planned, built, and managed. Unlike many modern cities that evolved through decades of rapid expansion, congestion, and unplanned growth, Xiong'an is being developed according to a comprehensive long-term blueprint. Every district, transportation corridor, green space, and utility network is being integrated into a unified vision before construction is completed. One of the city's most remarkable features is its digital twin, a real-time virtual replica of the entire urban environment. This sophisticated system allows city managers to monitor and optimize everything from traffic patterns and energy consumption to environmental conditions and public services. Think of it as the city's digital brain, constantly analyzing data and making adjustments to improve efficiency and quality of life. More than 25 government agencies are involved in the project, overseeing sectors such as education, healthcare, transportation, technology, and economic development. Xiong'an is also expected to receive relocated universities, research centers, and state-owned enterprises, helping reduce pressure on Beijing while stimulating growth throughout the Beijing-Tianjin-Hebei region. Yet technology is only part of the story. Xiong'an has been designed as a green city as well. Urban construction is limited to approximately 30% of the total area, leaving substantial space for parks, wetlands, and ecological preservation zones. Geothermal energy systems provide sustainable heating, while renewable energy infrastructure is integrated throughout the city. By 2035, Xiong'an is expected to be home to roughly 5 million residents. It aims to become a city powered by clean energy, supported by artificial intelligence, and designed around people rather than automobiles. More than a construction project, Xiong'an represents China's vision of what future urban life could look like. But while China is building its future on Earth, it is also extending its ambitions far beyond our planet. 16. Tiangong Space. If Xiong'an represents China's vision for the future on Earth, Tiangong represents its vision in space. Orbiting hundreds of kilometers above the planet, Tiangong, meaning heavenly palace, is far more than a space station. It is China's permanent foothold in low Earth orbit. After being excluded from participation in the International Space Station program, China chose a different path. It decided to build its own station, and it succeeded. The journey began with Tiangong-1 in 2011 and Tiangong-2 in 2016. These early experimental stations served as technological testbeds, allowing engineers to develop critical systems for long-term human spaceflight. The decisive step came on April 29, 2021, when the Tianhe core module was launched into orbit. Soon afterward, cargo spacecraft and crewed missions followed, transforming a single module into a fully functioning orbital laboratory. Today, Tiangong consists of 3 major modules: Tianhe, Wentian, and Mengtian. Completed in 2022, the station typically supports 3 astronauts for missions lasting up to 6 months, although it can accommodate 6 crew members during rotation periods. While smaller than the International Space Station, Tiangong is equipped with advanced technologies and state-of-the-art scientific facilities. Inside the station, astronauts conduct research in life sciences, materials science, medicine, physics, and astronomy. The knowledge gained from these experiments will contribute to future missions to the Moon, Mars, and potentially even deeper destinations in the solar system. Tiangong is more than a scientific laboratory. It is a strategic platform for the next phase of China's space program. Every mission launched to the station strengthens the nation's technological capabilities and expands its experience in long-duration human spaceflight. This is not merely a space project. It is a declaration that China intends to remain a major player in the exploration of space for decades to come. And while Tiangong reaches toward the stars, another Chinese innovation is helping power the nation below. 15. Jiangbei Flexible DC Grid. Imagine a highway that transports energy instead of vehicles. That is essentially what the Jiangbei flexible DC grid was designed to do. This groundbreaking network serves as a green superhighway, delivering vast quantities of renewable energy from northern China directly into major population centers, including Beijing. But this is far from an ordinary transmission system. Jiangbei is the world's first meshed four-terminal voltage source converter, high-voltage direct current grid, commonly known as a VSC HVDC grid. Developed by the State Grid Corporation of China, the system connects Jiangbei, Kangbao, Fengning, and Beijing through a highly flexible ring-shaped network. Think of it as an intelligent energy-sharing system capable of directing electricity wherever it is needed most. Construction began in 2018, and the network successfully entered operation in 2020. Its primary mission was to transmit up to 4.5 gigawatts of renewable energy while supporting the Beijing 2022 Winter Olympics with a reliable supply of green electricity. But its long-term impact extends far beyond a single event. The system can deliver approximately 14.1 terawatt-hours of clean energy every year, reducing carbon dioxide emissions by an estimated 12.8 million tons annually. That is equivalent to removing millions of conventional vehicles from the road. Perhaps even more importantly, the grid helps solve one of renewable energy's greatest challenges: intermittency. Wind power is not always available when demand is highest. By integrating with large-scale pumped hydroelectric storage facilities, the Jiangbei network can balance fluctuations and maintain a stable flow of electricity. The result is a cleaner, more reliable power system capable of supporting future economic growth while reducing dependence on fossil fuels. This project demonstrates that the future of energy is not only about generating more renewable power, it is also about delivering, managing, and storing that power intelligently. And if Jiangbei is the superhighway of China's clean energy network, the next project is one of its most powerful engines. 14. Baihetan Hydropower Station. If the Jiangbei flexible DC grid is the green superhighway of China's energy system, then Baihetan Hydropower Station is one of its most powerful engines. Rising from the Jinsha River, a major tributary of the Yangtze, this colossal hydroelectric facility represents one of the greatest engineering achievements in modern energy infrastructure. With an installed capacity of 16 gigawatts, Baihetan is the second-largest hydroelectric power station in the world, surpassed only by the Three Gorges Dam. To put that into perspective, it generates enough electricity to power tens of millions of homes. The dam itself stands nearly 300 meters tall, forming a massive concrete barrier that dominates the surrounding landscape. But size alone does not define Baihetan. The project incorporates sophisticated flood control systems, advanced sediment management technologies, and extensive safety mechanisms designed to ensure reliable operation for decades. Every aspect of the facility was engineered to maximize efficiency while minimizing long-term environmental impact. Environmental protection was also a major consideration during construction. Engineers implemented ecological conservation measures aimed at protecting aquatic habitats and maintaining the health of local ecosystems. The project demonstrates how large-scale renewable energy development can be combined with environmental stewardship. Strategically, Baihetan plays a crucial role in China's transition away from coal. By generating enormous quantities of renewable electricity, the station helps reduce carbon emissions while strengthening the stability of the national power grid. This is hydropower on an extraordinary scale, a combination of engineering excellence, environmental planning, and long-term energy strategy. Yet even projects as massive as Baihetan are only part of China's broader infrastructure vision. Because sometimes innovation is not about generating power. Sometimes it is about connecting people. 13. Record-breaking arch bridges. China's engineering ambitions are visible everywhere, even in something as seemingly simple as a bridge. But when China builds a bridge, simplicity often gives way to extraordinary scale. Take the modern steel arch bridge. Elegant, efficient, and visually striking, this centuries-old concept has been transformed through advanced materials, modern engineering techniques, and unprecedented construction speed. The beauty of an arch bridge lies in its ability to distribute forces naturally. As weight is applied to the structure, the arch channels those forces through its curved form and into the foundations below. This allows enormous loads to be supported, while maintaining a graceful appearance. It is an engineering principle first mastered by the Romans, but modern China has pushed it to entirely new levels. Projects such as the Pingyan Third Bridge and several other record-breaking arch structures demonstrate just how far the technology has evolved. These bridges span vast rivers, deep valleys, and challenging terrain that would have been considered nearly impossible obstacles only decades ago. What makes these achievements even more remarkable is the speed at which they are completed. While major infrastructure projects elsewhere may spend years navigating planning and approval processes, China often moves rapidly from design to construction. The result is a network of massive bridges that serve not only as transportation links, but also as symbols of technological capability. Rising high above rivers and mountains, these structures combine strength with elegance. Rather than dominating the landscape, many of them are designed to complement it. The result is infrastructure that feels integrated into its surroundings rather than imposed upon them. These bridges are more than transportation corridors. They are monuments to modern engineering, and every great bridge depends on a hidden component that most people never see: the skeleton that gives concrete its strength. 12. Automated steel rebar production. If bridges, dams, and skyscrapers are the muscles of a nation, then steel reinforcement bars, commonly known as rebar, are its skeleton. Invisible to the public once construction is complete, rebar is one of the most important materials in modern engineering. Concrete is exceptionally strong when compressed. However, it performs poorly under tension. Without reinforcement, even the largest structures would be vulnerable to cracking, bending, and failure. That is where rebar comes in. These steel rods are specifically designed to provide the tensile strength that concrete lacks. Before concrete is poured, rebar is cut, bent, shaped, and assembled into intricate frameworks. Once embedded within the structure, steel and concrete work together as a unified system. The concrete resists compressive forces, while the steel absorbs tensile stresses. The combination creates structures capable of enduring enormous loads for decades. China has transformed this process through automation. While many construction sites around the world still rely heavily on manual labor for rebar preparation and assembly, China increasingly uses highly automated production systems. Advanced machinery cuts and bends steel bars with exceptional accuracy. Robotic systems assemble reinforcement cages and mesh structures with speed and consistency. Artificial intelligence assists in planning layouts and monitoring installation quality in real time. Tasks that once required days of labor can now be completed within hours. The benefits extend beyond efficiency. Greater precision results in stronger structures, fewer construction defects, and improved long-term durability. Every accurately positioned reinforcement bar contributes to a safer and more reliable finished project. This level of automation reflects a broader trend across Chinese infrastructure development. The focus is not simply on building faster, it is on building smarter. And once the skeletal framework is complete, another material takes center stage: the substance that forms the backbone of nearly every mega project on Earth. 11. Concrete megastructures. In the world of mega projects, concrete is far more than a construction material. It is the foundation upon which modern civilizations are built. No country demonstrates this better than China, where concrete is used on a scale that often seems almost unimaginable. We are talking about projects that require millions of cubic meters of concrete. enough to build entire cities, massive dams, high-speed rail networks, and some of the largest bridges on Earth. What might take years to complete elsewhere can often be accomplished in a fraction of the time through advanced planning, industrial-scale production, and highly coordinated construction methods. China's ability to build at such speed is not simply the result of labor or resources. It comes from an ecosystem designed around efficiency. Large-scale batching plants, prefabrication facilities, automated quality control systems, and sophisticated logistics networks allow construction to proceed around the clock. The result is a level of productivity rarely seen anywhere else. Major international engineering firms have also contributed expertise to many large infrastructure projects around the world. Companies from Europe and other regions often bring decades of experience in structural design, materials science, and project management. Meanwhile, Chinese construction organizations contribute unmatched speed, manufacturing capacity, and execution capabilities. Together, these approaches are helping redefine how quickly large-scale infrastructure can be delivered. Across China's landscape, concrete has become the physical expression of national ambition. From bullet train corridors, stretching thousands of kilometers, to dams towering above mountain valleys, nearly every mega-project begins with this versatile material. Every beam, pillar, tunnel lining, and foundation tells the story of a nation building at extraordinary scale. But even the strongest concrete structure depends on energy, and China has learned that maximizing energy production sometimes comes down to something as simple as keeping a surface clean. 10. Robotic solar panel cleaning. At first glance, a solar farm appears peaceful. Rows upon rows of photovoltaic panels stretch toward the horizon, silently converting sunlight into electricity. But behind that calm appearance lies a constant challenge: dust. Even a thin layer of dirt can significantly reduce the efficiency of a solar panel, cutting energy production by as much as 30% in some environments. For a large solar installation, that can mean substantial losses in power generation and revenue. This challenge is particularly important in China, where some of the world's largest solar farms are located in deserts, plateaus, and arid regions prone to dust accumulation. Cleaning these facilities is not simply routine maintenance. It is an essential part of maximizing energy output. Rather than relying solely on large teams of workers, China increasingly deploys robotic cleaning systems designed specifically for solar installations. These autonomous machines move across panel arrays with remarkable precision. Depending on the application, they may use soft rotating brushes, compressed air systems, or water-free cleaning technologies to remove dust without damaging the surface. The advantages are significant. What would take human crews days to complete can often be accomplished overnight. Integrated sensors continuously monitor dust accumulation and automatically schedule cleaning operations when performance begins to decline. Artificial intelligence helps optimize maintenance schedules, ensuring that every panel operates as efficiently as possible. The goal is simple: capture every possible watt of energy from the sun. By maximizing efficiency across thousands of square kilometers of solar infrastructure, China strengthens its renewable energy network while reducing operating costs. It is a reminder that technological leadership is not always about building bigger systems. Sometimes it is about optimizing the smallest details. And while solar farms generate electricity, across deserts and open plains, another construction method is helping China build transportation networks at remarkable speed. 9. Prefabricated viaduct construction. When many countries plan major infrastructure projects, years can pass before construction truly begins. China often takes a different approach. Rather than building every component directly on-site, engineers increasingly rely on large-scale prefabrication techniques. The result is faster construction, improved quality control, and greater efficiency. One of the best examples of this approach can be seen in modern viaduct construction. Large bridge segments are manufactured in controlled production facilities before being transported to the construction site. Each segment is produced with extreme precision, ensuring that every piece fits perfectly during assembly. Instead of building structures section by section using extensive scaffolding and labor-intensive methods, China often uses massive launch gantries, specialized machines capable of lifting and placing enormous concrete segments with extraordinary accuracy. Imagine a giant mechanical arm stretching across a valley, positioning hundreds of tons of concrete exactly where it needs to be. Segment by segment, the bridge advances forward. The process resembles a giant puzzle being assembled high above the ground. The advantages are substantial. Prefabrication improves consistency, reduces weather-related delays, minimizes disruption on site, and significantly enhances worker safety. Quality inspections can also be performed before components leave the factory, ensuring a higher standard of construction. This approach has allowed China to construct thousands of kilometers of elevated highways and high-speed railway viaducts in remarkably short periods of time. The strategy demonstrates that speed and quality do not have to be opposing goals. With proper planning, advanced equipment, and industrial-scale production, infrastructure can be delivered both quickly and reliably. These viaducts are more than transportation structures. They are symbols of a construction philosophy focused on precision, efficiency, and innovation. And while bridges reshape the landscape on land, China's ambitions increasingly extend offshore, where some of the most powerful renewable energy projects are now taking shape. 8. Offshore floating wind farms. Far from the coastline, where waves roll across the horizon and winds blow with relentless force, a new generation of renewable energy infrastructure is taking shape. Unlike traditional offshore wind farms that are anchored directly to the seabed, floating wind farms operate in much deeper waters, where stronger and more consistent winds can be captured. This innovation is opening vast new areas for clean energy development. One of the most notable examples is Windfloat Atlantic, located off the coast of Portugal. As the first semi-submersible floating wind farm in continental Europe, the project demonstrated that offshore wind turbines no longer need to be restricted to shallow coastal regions. Instead, they can be deployed in deep-water environments previously considered inaccessible. Floating platforms support massive turbines, while sophisticated stabilization systems keep them operating safely despite waves, currents, and changing weather conditions. The benefits are substantial. Stronger winds mean higher energy production and improved efficiency. At the same time, floating installations reduce visual impacts near shore and expand the number of potential locations for renewable energy projects. China has rapidly emerged as one of the world's leading forces in offshore wind development. Its extensive coastline, advanced manufacturing capabilities, and growing expertise in marine engineering have positioned the country at the forefront of this industry. Chinese companies are developing larger turbines, more efficient floating platforms, and streamlined supply chains capable of supporting massive offshore deployments. What began as a regional energy solution is evolving into a global industry. Floating wind technology represents one of the most promising frontiers in renewable power generation. As nations search for ways to reduce carbon emissions while meeting rising energy demand, the open ocean may become one of the most important sources of clean electricity in the decades ahead. And while offshore wind farms help generate energy, another category of giant machines helps move the goods that power the global economy. 7. Giant gantry cranes and smart ports. When a container ship the size of a small town arrives at a port, unloading its cargo requires far more than manpower. It requires some of the largest and most sophisticated machines ever built. Enter the giant gantry crane. Towering above docks and shipping terminals, these steel giants form the backbone of modern global trade. Their job is deceptively simple. Move containers as quickly, safely, and efficiently as possible, In practice, however, the operation requires extraordinary precision. Modern gantry cranes can lift hundreds of tons while positioning cargo with centimeter-level accuracy. Advanced sensors, automation systems, and computerized controls allow operators to coordinate complex movements with remarkable efficiency. What once required large teams of workers can now be performed with minimal human intervention. China has become a global leader in this field. Its ports rank among the busiest in the world, handling enormous volumes of cargo every year. Facilities such as the Port of Shanghai rely on highly automated crane systems that operate around the clock. Many of these cranes incorporate artificial intelligence, automated scheduling, and real-time monitoring systems that optimize performance and reduce delays. Some terminals have even achieved levels of automation that would have seemed impossible only a generation ago. Containers move seamlessly from ships to storage yards, trucks, and rail systems with minimal interruption. The result is faster logistics, lower operating costs, and increased efficiency throughout the supply chain. These cranes are more than industrial equipment. They are critical components of the global economy. Without them, international trade would slow dramatically. Every product that crosses an ocean, from electronics and vehicles to food and raw materials, depends on infrastructure like this to reach its destination. But moving energy and goods efficiently is only part of the challenge. The next breakthrough focuses on storing energy itself. 6. Pumped hydro energy storage. One of the greatest challenges facing renewable energy is not generation, it is storage. The sun does not always shine. The wind does not always blow. Yet homes, businesses, and industries require electricity every hour of every day. This is where pumped hydroelectric storage becomes invaluable. Often described as a giant natural battery, pumped hydro storage allows excess energy to be stored and released whenever needed. The concept is surprisingly simple. When electricity is abundant and inexpensive, typically during periods of strong wind or intense solar generation, water is pumped from a lower reservoir to a higher one. Later, when demand increases, the stored water is released back downhill through turbines. As it flows, it generates electricity that can be fed directly into the grid. The process is highly efficient, reliable, and capable of operating on a massive scale. Unlike conventional batteries, which gradually degrade over time, pumped hydro facilities can continue operating for decades with proper maintenance. Countries around the world use this technology to stabilize their electrical grids, but China has embraced it more aggressively than any other nation. As renewable energy capacity continues to expand, China is constructing an extensive network of pumped hydro facilities designed to balance fluctuations in solar and wind generation. These projects act as strategic reserves of energy, helping ensure that electricity remains available even when weather conditions change. In many ways, pumped hydro is the hidden foundation of a renewable-powered future. While solar panels and wind turbines often attract the headlines, storage systems are what make large-scale renewable energy practical. They transform intermittent energy sources into dependable infrastructure capable of supporting entire economies. Water, one of humanity's oldest energy resources, is once again proving its value, not just as a source of power, but as a way to store it for when the world needs it most. And once that water begins to move, another engineering marvel comes into play: the turbines that convert its immense force into electricity. 5. Hydroelectric turbine manufacturing. Every hydroelectric dam depends on one critical component: the turbine. Hidden deep within massive power stations, these machines transform the force of moving water into electricity for millions of people. But before a turbine can generate power, it must first be built. The process begins in enormous foundries where specialized steel alloys are melted at extreme temperatures. The molten metal is poured into giant molds, creating the foundations for some of the largest rotating machines ever engineered. After cooling, the components undergo extensive machining and refinement. This is where raw metal begins its transformation into a precision instrument. Advanced multi-axis CNC machines carve turbine runners and blades with extraordinary accuracy. Every curve, angle, and surface is carefully designed to maximize efficiency while minimizing turbulence. Even the smallest imperfection can reduce performance over decades of operation. The blades themselves are engineering masterpieces. They must withstand immense hydraulic pressure while maintaining perfect balance under constant stress. Designed to operate continuously for years, they convert the kinetic energy of flowing water into rotational motion with remarkable efficiency. Once manufacturing is complete, rigorous testing begins. Engineers inspect every weld, surface, and structural component. Ultrasonic scanners and other non-destructive testing technologies search for microscopic defects that could compromise long-term reliability. Only after passing extensive quality control procedures can a turbine be approved for installation. China has become one of the world's leading producers of hydroelectric equipment. Projects such as the Three Gorges Dam and Baihetan Hydropower Station have driven the development of some of the largest and most advanced turbines ever constructed. These machines are capable of generating enormous quantities of clean electricity while operating with exceptional reliability. Hydroelectric turbines represent the intersection of metallurgy, precision manufacturing, and energy engineering. Forged in fire and powered by water, they are among the most important machines in the modern world. But while turbines harvest the power of rivers, another type of engineering marvel takes to the skies. 4. Helicopter production. A helicopter is one of the most complex flying machines ever developed. Unlike conventional aircraft, it can take off vertically, hover in place, maneuver in tight spaces, and operate in environments where fixed-wing aircraft cannot. Building one requires extraordinary precision. The process begins with high-strength alloys and advanced composite materials. Large sections of the fuselage are formed using specialized manufacturing techniques designed to maximize strength while minimizing weight. Every structural component must withstand intense vibrations, aerodynamic forces, and constant operational stress. Once the airframe is assembled, attention shifts to the powertrain. The engines, transmission systems, gearboxes, and drive shafts form the mechanical heart of the aircraft. Thousands of precisely manufactured components must work together seamlessly to transfer power from the engines to the rotor system. The rotor blades are perhaps the most critical elements of all. Each blade must be manufactured and balanced with extraordinary accuracy. Even a minor imbalance can create severe vibrations capable of affecting performance, safety, and structural integrity. Modern rotor systems combine lightweight materials with advanced aerodynamic designs, allowing helicopters to operate more efficiently than ever before. After assembly, extensive testing begins. Engineers conduct ground evaluations, vibration analyses, and performance assessments before the aircraft ever leaves the runway. Only after passing a series of increasingly demanding flight tests can a helicopter be certified for operational use. China's aerospace industry has expanded rapidly in recent years. The country now produces helicopters for military, commercial, emergency response, and industrial applications. Aircraft such as the Z-20 demonstrate the growing sophistication of China's rotary wing aviation sector. These helicopters perform a wide range of missions, from search and rescue operations and disaster response to offshore transportation and military support. What began centuries ago as inspiration drawn from spinning seeds falling through the air has evolved into one of humanity's most versatile flying machines. Yet even helicopters depend on something even more remarkable: the engines that make flight possible. 3. Turbojet engine manufacturing. If aircraft are symbols of modern aviation, then jet engines are the technological masterpieces that make them possible. Few machines operate under conditions as demanding as a modern turbojet or turbofan engine. Inside the combustion chamber, temperatures can exceed 150 to 100 degrees Celsius. Rotating components spin at thousands of revolutions per minute, while enduring immense mechanical stress. Building such a machine requires some of the most advanced manufacturing techniques on Earth. The process begins with nickel-based superalloys specially developed to withstand extreme heat and pressure. These materials are melted and cast into carefully engineered shapes before undergoing multiple stages of forging and machining. Among the most critical components are the turbine blades. Manufactured with micron-level precision, each blade must be virtually identical to every other blade in the engine. Even tiny imperfections can reduce efficiency or create dangerous mechanical imbalances. To survive extreme operating temperatures, the blades receive specialized thermal coatings and advanced heat treatments. These protective layers allow them to function in environments that would destroy ordinary metals. Next comes the combustion chamber, the engine's powerhouse. Here, compressed air mixes with fuel and ignites, creating a continuous stream of high-energy gases. These gases expand rapidly, spinning turbine stages and generating the thrust needed to propel aircraft through the sky. Once assembly is complete, the engine undergoes extensive testing. Mounted on specialized test stands, it is pushed to its operational limits under carefully controlled conditions. Engineers monitor temperature, pressure, vibration, fuel consumption, and performance characteristics to ensure reliability. For decades, the jet engine industry was dominated by a small group of manufacturers from the United States, Europe, and Russia. Today, China is investing heavily in the development of indigenous engine programs. Projects such as the CJ1000A represent major efforts to strengthen domestic aerospace capabilities and reduce reliance on foreign technology. Jet engine manufacturing is one of the most demanding fields in modern engineering. It combines materials science, precision machining, thermodynamics, and advanced aerodynamics into a single machine capable of defying gravity. It is not simply manufacturing, it is the pursuit of technological mastery itself. And while jet engines power aircraft, another class of giant machines helps build the infrastructure that shapes the modern world. 2. Giant crane production. They do not fly, generate electricity, or travel at high speeds. Yet without them, many of the world's largest infrastructure projects would never leave the drawing board. Giant cranes are among the most important machines in modern construction. From skyscrapers and shipyards to bridges, ports, and wind farms, these engineering giants make it possible to lift, position, and assemble structures that weigh hundreds or even thousands of tons. Their construction begins with massive sections of high-strength steel. Each beam, support structure, and connection point is carefully engineered to withstand extraordinary loads while maintaining stability and precision. Because when a crane lifts hundreds of tons into the air, there is no room for error. Once the structural framework is complete, hydraulic systems, electric motors, control systems, and counterweights are installed. Together, these components form a machine capable of moving enormous loads with remarkable accuracy. Modern cranes are far more sophisticated than many people realize. Advanced sensors continuously monitor load distribution, wind conditions, and structural stress. Computerized control systems help operators perform complex lifts safely and efficiently. Some cranes can even coordinate with other machines, allowing multiple units to work together during particularly challenging operations. Before entering service, every crane undergoes rigorous testing. Engineers verify lifting capacity, structural integrity, operational precision, and safety performance under demanding conditions. Only after passing these evaluations can the machine be deployed to construction sites around the world. China has become one of the leading manufacturers of heavy lifting equipment. Companies such as Sany and Zoomlion produce some of the largest cranes ever built. These machines are exported globally and play a vital role in infrastructure development across multiple continents. From offshore wind farms and hydroelectric dams to ports and industrial facilities, giant cranes are helping shape the modern world. They are not merely construction equipment. They are force multipliers that allow human ambition to be transformed into physical reality. And while cranes help build massive structures, another class of machines helps reshape the earth itself. 1. Giant mining dump trucks. Few machines inspire a sense of scale quite like a giant mining dump truck. These enormous vehicles are among the largest land machines ever created, capable of transporting hundreds of tons of material in a single trip. They are the workhorses of mines, dams, highways, and large-scale infrastructure projects around the world. Their construction begins with an ultra-heavy-duty steel chassis designed to withstand extreme operating conditions. Every component must endure immense forces generated by rough terrain, heavy loads, and continuous operation. Balancing strength, durability, and stability is one of the greatest engineering challenges in the design process. Once the structural framework is complete, and powerful diesel-electric or conventional power systems are installed, these engines generate thousands of horsepower, allowing the trucks to move astonishing quantities of earth, rock, and construction materials. Hydraulic systems provide the lifting force required to raise and unload massive payloads efficiently. The wheels alone are engineering marvels. Some stand taller than an average person and are specifically designed to operate under crushing loads while maintaining traction across difficult terrain. Before entering service, these trucks undergo extensive testing. Engineers evaluate performance on steep inclines, rough surfaces, and under maximum load conditions. Every system must demonstrate reliability before the vehicle is approved for operation. China's infrastructure boom has fueled the development of increasingly powerful heavy-haul vehicles. Machines such as the XCMG XDE 440 represent the cutting edge of mining and construction transportation technology. Capable of hauling more than 400 tons in a single load, these trucks operate like mobile industrial giants. Day and night, they move the raw materials required to build highways, railways, bridges, dams, and cities. They may not receive the same attention as high-speed trains or space stations, but they are essential to the projects that shape the modern world. These vehicles are not simply trucks. They are symbols of industrial capability, operating at a scale that few people ever witness firsthand. From the depths of the South China Sea to the vastness of outer space, China's mega projects reveal a nation pursuing technological advancement on an extraordinary scale. Each project serves a specific purpose. Deep-sea energy platforms strengthen energy security. Bridges and tunnels connect cities. Nuclear reactors and renewable energy systems power economic growth. Space stations expand scientific capabilities. Ports, cranes, turbines, and manufacturing facilities support industries that reach every corner of the globe. Individually, these projects are impressive. Together, they tell a much larger story. They demonstrate how infrastructure, technology, manufacturing, and long-term planning can be integrated into a single national strategy. Whether one views these developments as competition, inspiration, or a glimpse of the future, one fact is difficult to ignore. The scale is immense, the pace is remarkable, and the ambition is unmistakable. Every bridge, tunnel, turbine, reactor, spacecraft, and industrial machine represents more than engineering. They represent a vision of what can be achieved when resources, technology, and determination are combined on a massive scale. The future is not being imagined, it is being built, and the world is watching. What do you think? Which of these projects impressed you the most? Let us know in the comments below. Thank you for watching, and we will see you in the next video.